I am Lauren Wolfanger, and this is a Chapter 2 reassessment. A steel safe with mass 2,200 kilograms falls onto concrete. Just before hitting the concrete, its speed is 40 meters per second, and it smashes without rebounding, and ends up being 0.06 meters shorter than before. What is the force exerted on the safe by the concrete? First, I'd like to point out that the initial velocity was given as 40 meters per second. Final velocity is 0 meters per second. The change in R was denoted as 0.06 meters, and the mass is 2,200 kilograms. Now, before we go any further, we like to see what we're going to use to solve this problem. We are going to use the momentum principle. But what does the momentum principle state? The momentum principle says that the net force of an object is equal to the change in momentum over the change in time. So let's start with our change in time. If we take the average velocity formula, we can rearrange it so that the change in time equals the change in R over the average velocity. But what is the average velocity? If we take our 40 meters per second and subtract 0 meters, we end up with 40 meters, divide that by 2, and our average velocity is 20 meters per second. Plug that into our change in time equals change in R over average velocity formula, and we see that the change in time is 0.003 seconds. Now, the change in momentum. Change in momentum is simply the final momentum minus the initial momentum. Momentum is mass times velocity. So to get our initial momentum, we have to multiply our mass, 2,200 kilograms, times our initial velocity, which is 40 meters per second, giving us 88,000 kilograms times meters per second. Our final velocity is 0 due to the fact that our final velocity was 0. So our change in momentum is 0 minus 88,000, giving us negative 88,000 kilograms times meters per second. All we have left to do is plug that into our net force formula, change in P over change in T. Our change in momentum was negative 88,000. Divide that by 3,000ths of a second, and we end up with negative 2.93 times 10 to the 7th newtons.